allow you to get that kind of precision. So my goal is to always have 1 0 past the decimal place. Now we're going to take and save data at each angle of attack by sending samples to file. So that's this button right here in the top left. Send samples to file, and then it will increment and tell me how many samples I've sent. That way it's a time ticker or a place ticker to know how many samples you've taken in case you miss an angle of attack. Because it goes so quickly, sometimes you don't remember, did I get -5 or did I forget -5? So this is a way to keep track of how many samples you've sent to the file. We're going to take and do all of our angles of attack for the wind turned off first. So we start at -7, save samples. Oops, I went the wrong direction. Going clockwise is going to raise the angle of attack. So you might want to write that down if that helps. Otherwise, I just do it by trying it and going the other way. There is a little bit of hip slop in the mechanism, so you'll have to be careful about that. That'll be one of your testing challenges. So we're at -5, and then we'll send samples to file. And then we'll do that all the way up to our most positive angle of attack. Why is that important? Why are we doing that? Why do we need to do it with the wind turned off? Is the weight of the plane negligible? No. So as we move this, you can see as I zoom in on this plot, I put -0.3 newtons of axial force. That's how much the plane weighs and is pulling down on the sting balance. And that's how accurate our sting balance can measure, which is pretty amazing. That's why it's a $55,000 wind tunnel. So as we move this up an angle of attack, you can see the weight of the plane as it translates back up to level, near 0 angle of attack. And then as we go into positive angles of attack, the weight of that plane is now pushing down and causing a positive axial force. So you'll need to take those offsets out when you do lift and drag, because that contribution measurement on the balance is not part of your lift and drag measurement. So you'll have to take the difference. You'll have to take what was the normal in axial before wind, or sorry, after wind, minus with the wind off, and then that difference is due to lift and drag. Make sense? Okay, so you'll do that. Go up to your highest angle of attack, each time hitting send samples to file. If you're not sure if you saved a data set, or maybe I accidentally hit the button twice because I got too excited, you can check the data file. You can actually open up the data file by going to where you saved it in your Z folder. So go to your personal folder and open up the file that you saved. It's okay to open the file while the VI is running. Do not stop the VI until you're sure you have all the data. The VI can keep running even though you're checking, okay? And I don't want you to stop the VI because then you'll lose your 0 reference. And if you go to try to level the plane again, it might be slightly different. Okay, so we want to keep that reference consistent for each test. So if you go over to column W, that's going to be your angle of attack. And you can see that I got -7 and -5. And if I needed to, I could scroll down to the bottom and see where I left off. I can also go through and check and make sure I got all the angles of attack. Okay? Now, make sure if you're checking, you close the spreadsheet again. Because if it's open and the VI tries to write to it, it can't write to an open file. So you just have to close it again and then it can add more data. Okay? So you can go back, do whatever angle of attack you forgot. Let's say you forgot 12. Go back, add that one in. Then we want to go back to negative. Remember, we always start from attached flow and go up to separated flow. So we're going to go back to our negative angle that we started at. -7, because we've completed all of our wind off measurements. Now we're going to go back through those same angles of attack with the wind dialed up to 25 meters per second. So we dial up that airspeed. And then from there, you can see the forces that are applied in the pitching moments to the airplane. Okay, I'm going to turn that down a little bit just so you can hear me talk. You'll do the same thing, starting with your negative angle of attack, your airspeed turned up. Notice that sometimes when the airspeed turns on, it'll actually move the airplane a little bit, because the angle of attack mechanism does not have a lock. So you'll want to make sure that you double check and adjust that if necessary to the correct angle of attack. Double check your angle, double check your airspeed. Once those two check, then hit send samples to file. And do that for each angle of attack. Checking at each airspeed. The good thing is you don't have to adjust the airspeed, but you do need to give the controller time to adjust the airspeed. So as you're going through these angles of attack, as the plane moves, it's going to block more blocked area of the wind tunnel when it's at high or low angles of attack. When it's at level flight, it doesn't block much of the flow at all. So the controller doesn't have to work as hard. But you will need to give it some time, especially at the high and low angles of attack, to adjust for that. In the past, just 2 years ago, I think our seniors now, they had to adjust the voltages manually because we didn't have computer control for that airspeed. So it took the testing a lot more time, and it was hard to get all the groups through, especially as the curriculum's grown. So this has been a great new addition to our wind tunnel, to now have that controlled by the MyRio software to adjust our airspeed for us. So just make sure you give it some time to be consistent. Now don't be too picky, it's not going to be exactly 15.000 or 25.000 meters per second, but it shouldn't be changing, it should be consistent. And the way you can tell that is if the pressure line is flat. So if that's consistent, and you don't see a lot of variation between plus or minus 0.2, that's about our error, 0.2 meters per second, 0.3 meters per second, then you're good to go to send samples to file. Okay? So you'll translate that through each time, making sure you send samples to file for each angle of attack. Do a count to make sure how many angles of attack you're measuring and how many you've sent. And then go back and open up your data file and make sure that all of your angles of attack are in there. It's going to take 20 samples times however many angles of attack, so you can also look at the index and see how many lines of data and if that's the correct number of lines. But also double check to make sure you didn't do -9 twice. Or not -9, don't do -9. -6 twice, or some number twice. You want to have one unique for each one. Okay? If not, if you missed a number, if you duplicated a number, that's okay. Don't delete it here just yet. If you need to add data, that's fine. Just go back to that missing angle of attack on the VI, whichever one it was. If you're missing an angle, set that angle of attack, make sure the airspeed is good, and add that extra samples of data. See, it won't let you if the VI, if the folder is open. So hit continue, close the file, and then send samples when the file is closed. Then later, after you stop the VI and go back to the lab stations, if you need to fill in that missing 10-degree data point, you just take those chunk of 20 data and manually manipulate the spreadsheet to put it in the right place. Make sure you do that before you save the data with the rest of the class, or you're going to really irritate the rest of the groups having your data out of order, right? Okay, any questions? Yes?
So will we get like a complete set of data across all the planes in just one lab period, or will it be across all the lab periods as well?
All the lab periods, yep. So it'll take the next 3 weeks to get all the data. But as the data is coming in, and as you're working on the data analysis, you can use the data set that you have to get started, and then add in more as they come in. Good question. Any other question? Okay, that's it for today. Thank you very much, and we'll look forward to starting testing on Monday.